Hello class, good afternoon, good day, good morning, and good evening, whatever time you are watching this video. I'm Engineer Mark Paulo Alcala and I'll be your instructor for this subject, Engineering Hydrology. Okay, let me share to you my screen. Okay, so you can call me Sir Bogart. Okay, that's my nickname. Alright, so let's start. By the way, I've been in the academy for the past 10 years, and my mission is to teach and influence you to become the best version of yourself. Let's start. So for the longest time, this has been my course description for the subject. Weather and hydrologic cycle, primarily the water cycle. Precipitation, just a complicated term for rainfall, all right? Evaporation, transpiration, all of these hydrologic losses and infiltration. Groundwater flow and rainfall runoff relationships and how you compute and analyze those through hydrographs and discharge rating curves and storage and channel routing, flood and drought, and frequency analysis. And our objective is to introduce the basic knowledge of the water study, basically, okay? Because hydrology, from the term, is the study of water and its properties. And to enable students to apply the theory and methods through hydrological problems, especially in the practical interest of civil engineering. Okay. So here's our scope. Oh, by the way, you can screenshot this anytime. If you're having a hard time following the slides, you can pause and that's our edge in remote learning. We can learn at our own pace. And if you will have any questions, comment down in this video. Okay? Or message me or email me personally. And our references. Okay, let's start. Water resource engineering is essentially a complex study comprising the following: basic sciences, physical sciences, and social sciences. Okay? And from the term of the basic science, this is what we have studied ever since our elementary or formative years. Physics, biology, chemistry, our high school stuff or high school studies. But eventually, the complicated sciences takes a big part in this uh, complex study of water resource engineering. And part of it, of the physical sciences, is basically what our subject right now, which is hydrology. Okay? And talking also about geography, maps creation, study of places, right? And geology, study of rocks and its properties, or study of the earth. And for social sciences, we deal with economics, political science, and sociology. All of these are parts of the complex study of water resource engineering. Why physics? Because you have computation. Why biology? Anything that has water has life, right? And sociology, we are affected every time there's a water shortage, right? In Manila water, because it's the study of the behavior of people, right? Social sciences. Now let's define properly what is hydrology. Okay, what is hydrology? Hydrology is that natural science that is concerned with the occurrence, properties, distribution, and movement of water in the natural and man-made environment. What do we mean by natural environment? Meaning that is what is already existing since the creation. All right. So in reality, all you have are reservoirs, right? Uh, Man-made environments, that the one that we alter, but for also for the purpose and for the benefit of human life. Okay. So the gigantic dams, those are alteration, right? La Mesa Dam, Angat Dam, all of those things are alteration. Okay? And primarily, uh, we made those stuff, or we made those engineers or builders create those dams in order for you to improve essentially the quality of life of people. Okay? Some additional terms from the term hydro, or the Greek term of water, no? And logos, the study or reasoning, the study of water. The study of water and its properties. It's a big part of water management for us to use water sustainably for the next generation to conserve it. So some may have altered the hydrologic cycle because of our behavior. What do we mean by this? Manipulating the hydrologic cycle, meaning we alter the cycle through too much global warming, right? Too much plastic usage. Okay, and there are other types that, for example, there is a modern technology that you can the term is called cloud seeding. Okay, meaning you create clouds through the air for you to provide rain. Cloud seeding, and eventually the rain will fall for those places that are lacking of water or lacking of precipitation. So we can through modern technology we can manipulate the hydrologic cycle. Hydraulic structures such as for water supply, water treatment, wastewater treatment, disposal, irrigation, and so on and so forth. What is the hydrologic cycle basically? It is our water cycle, okay? As I said earlier, it is just a complicated term. Okay, pinahaba. In a global sense, the occurrence, distribution, and movement of water in the natural environment can be visualized through a cyclic process known as the water cycle or the hydrologic cycle. So in our masteral or in the graduate studies, there's a deeper study of water resources management, which takes hold of water resources planning. Okay, the identification, formulation, and analysis of projects for the sake of people. So you are dealing with scientific, not just in sciences, no, but also in law. You're dealing with rules, Clean Water Act, diba? And ethical and economic considerations. So some problems that are covered in this subject, actually we have a special subject of water resources planning in a specialized course in masteral sa graduate studies. So some of the problems considered: industrial water usage, irrigation. So primarily being a tropical country and about 60-70% of our land are suitable for farm. We must maximize our irrigation. No? Flood control, hydroelectric power, water resources for navigation, water quality, part of environmental engineering, fisheries recreation, drainage sediment control for sediment transport and analysis, and preservation of water areas for the future and next generation. So here's a project of mine located in where's this? Iloilo, Lower Iloilo, wherein you have supposed to be you should have a gate there, okay? A water for you to, or a bridge connecting, or a tunnel connecting the other farmland to the water source. But instead, they use a pump. So gagastos ka pa ng gas, no? Hindi na lang common sense. You can simply alter it so maximize the usage. Okay? Same thing in Iloilo. There's a project in of the part of the Halaur River multipurpose project. So as you can see here, the irrigation canal changed its cross section. But when I talk about the administrators there, why do you think, or why did they do this? Why do they have to limit the canal cross section? They don't know what to answer. Or the common answer is, of course, the right of way. But eventually, you cannot cross any road or any vehicle in this farmland. So why deal with right of way? I don't know. But those are just projects that are parang mahirap na mahirap kasi baka sabihin ng babackstab ako eh. Pero mamaya baka makatipid, no? Tinipid yung semento. Okay? So, but generally, we want the water, or for example, from this project, this is a lateral canal, meaning it's not directly connected to the river. Now, this is the main canal. This is the one directly connected to the Halaor River. What's the difference? Why is this one cemented? Why is this one non-cemented? There is a mistake when it comes to the design or the properties. The one that is connecting to the main source of water should be the one that is cemented. For you to avoid absorption, groundwater flow, and interflow, to minimize hydrologic losses. But that's not the case here. So, nagkabaliktad. Hindi natin alam bakit, sino yung mga designer niyan. Diba? Okay, so here's my team. This one is located in, I believe in Nueva Ecija. Okay. So here's another a picture of me biking. No, I want you to look on the tank, Bukawi Water District tank, no? So made up of concrete. Yung mga early design, no? Hindi pa yung mga elevated water storage na aluminum, steel. So the early designs are like this one. So this was located in Bukawi, yung flyover, malapit sa palengke. Okay. And this one is in our area in Valenzuela. There's a floodgate. Alright. So I used to cycle or bike around here, and since I just recreated my PowerPoint slides, maybe I can update it also. Okay. So this one, floodgate. And here's one, another one for the Angat Dam. Okay. Now let's look on this, a world of salt. So primarily, 97.5% of the, well, supposedly this for water resource engineering, no? But I gave you a background, an early background for this one. Salt water comprise about 97% of the earth. So imagine this, if you have 26 gallons of water, 3 tablespoons lang yung fresh water mo. Ganun katindi. That's the comparison that we can make. So, a water, we need to avoid salt water intrusion. Okay. Safer. Limit sa kaalaman ng iba. Water is limited. Okay. Our water resource is finite. Hindi siya unlimited. That's why we must do our part for the next generation. Let's look on this water consumption. This is an old slide, no? It's a very old slide and very old data. But look at the consumption. Maximize in Asia. Right? Bakit? Mainit. Lagi tayong naliligo. Sa mga malalamig na area, okay lang, kahit hindi. Charot. Hindi na alam. Probably because of the industry, right? Industrial revolution, primarily sa East, no? Or sa Asia. Okay? And by consumption, maximize pa rin ang agricultural. That's why I wonder why we still import rice. Right? Why we still import vegetables or fruits from other countries if we can maximize our agricultural sector. Okay? The global water cycle. So, you know this already. We will elaborate this further on. So water resource problems are, as I said earlier, it's very complicated and complex, interconnected and overlapping. That's why you need to decompose the following into different systems in order for you to break down or to solve one problem at a time. Okay? So for example, the problem of irrigation a while ago. What's the main problem there? Probably in the design, in the construction. Okay? That's why you must talk to the stakeholders. You must talk to the designers. You must talk to the agency involved, the National Irrigation Administration. Why? Why? Bakit nangyari to? Diba? Why is the design like this? So, transformation functions basically derive from the three differential equations of the following: conservation of mass, momentum, and energy. The good thing about hydrologic process is that the distribution is governed by the properties or the fundamentals of the earlier equation or the earlier uh, properties of this. Matter is neither created nor destroyed, same with energy, and any object acted by an external force accelerates, right? The conservation of momentum, and thus will give us the Reynolds transport theorem, which allows us to derive these fundamental principles, wherein the systems or the broken down components can be simply, or let's define first the system, no? Arbitrary quantity of mass of fixed identity. What comes in must come out. That's the simple definition of this one. Okay? And then, there's conservation of mass, conservation of momentum, and conservation of energy. Okay? For the transport processes from the massive energy of the sun, what happens? From the massive energy, it is either uh, released to the land and to the ocean. Dalawa lang babagsakan, tubig o lupa. Tama ba? And eventually, you can convert it. This one is your water cycle. Okay? Water absorption, water vapor, condensation, formation of clouds, and then rainfall. Okay? Evaporation. So, through processes that we can summarize this transport process is basically conduction and convection, wherein the conduction is the interchange of molecules between different layers or regions in a substance due to differences in temperature, velocity, and concentration. So basically, that's the conservation of energy, mass, momentum, matter, and momentum. And convection, the mechanism causing greater rate of exchange for the following properties than molecular exchange. So a quick summary of the hydrologic cycle. So wherein we can define first, the constant cyclic movement of water from the ground to the atmosphere and back to the ground. Okay? Wherein the following is what we already know ever since our elementary days. But in this module or in this subject, right, class, we will solve the following. Okay, magsosolve tayo. How do you solve for the evaporation? How do you solve for the precipitation? Okay, evaporation is basically the water that is converted into water vapor or into gas. Okay, through the massive energy of the sun. Transpiration, the process by which water vapor is emitted into the atmosphere from plant surfaces. So basically, maybe a combination of water, evapotranspiration yung tawag. Okay? So, precipitation, rainfall, trapped by the vegetation or by the plants or by the trees in the forest, never go down the land or fall down the land. Sana all pa-fall. Hindi siya nag-fall, just evaporate. Okay, evapotranspiration. Condensation, the process by which water vapor condenses back into liquid after it rises and cools to a specific temperature called the dew point, thus forming the clouds. Okay? Precipitation or the primary discharge or the primary input of the water cycle or the discharge of water to the atmosphere. Okay? Ito yung ulan. Okay? So, some other components, basically, you can summarize all of this through the groundwater flow. But eventually, we will, everything is one. Infiltration, surface runoff, ito yung discharge sa river, weathering, surface runoff, or floods. Okay? Pag water is, hindi na ma-consume. Okay? Or na-trap na, inundated. So, percolation, interflow, and groundwater flow basically can be summarized as groundwater flow. Okay? So that will be it for our lecture 1, and I hope you learned something today. That's an introduction for our subject, hydrologic,